Assalamualaikum warahmatullahi wabarakatuh. Today, in our 8th meeting, we will talk about wind rose. First of all, let's talk about the analysis of wind. Let's start with a question. How we determine the direction of a runway? As I said in the beginning of the semester, when an aircraft taking off or landing, it depends on the wind, especially a headwind. So, because of the obvious advantage of landing and taking off into the wind, runways are oriented in the direction of prevailing winds. For instance, if there is a wind blow from north to south, ideally the aircraft will take off or landing in south to north direction. Why? Because aircraft may not maneuver safely on a runway when the wind contains a large component at right or left angle to the direction of travel, or it is called by crosswind. Crosswind is a surface wind that is perpendicular to the runway center line. So what is the dangers of the crosswind? Here is some example in a picture how the dangers of the crosswind. Let's see here. If there is a crosswind, so an aircraft may have a rotation on itself, like here. So this is the effect if there is a crosswind during takeoff. Or this is another example. So if there is a crosswind when an aircraft taking off or landing, the aircraft will lose its stability. But if the pilot can make a movement in the aircraft, so it may not dangerous. And of course, the crosswind is not too big. And the other is, if there is a crosswind, the aircraft will not go straight in the middle of the runway or in the center line of the runway, but it will be moved to the left or the right side of the center line of the runway. And also I have a video about an aircraft that having a landing in the middle of the crosswind, and it is dangerous. So, because of the dangers of the crosswind, both ICAO and FAA made regulations so that runway should be oriented so that usability factor of the airport is not less than 95%. So what is usability factor is? The usability factor is the percentage of time during which the use of the runway system is not restricted because of an excessive crosswind component. So there is another question. How if a single runway has usability factor less than 95%? So one or more cross runway may need in order to have 95% usability factor. So here is the example. So if there is a single runway and the best direction of the runway is has the usability factor less than 95%, so this is the best usability factor that a runway has. So one or more cross runway may need. So if we have two runways, the usability factor is more than 95%. So how much the maximum permissible crosswind in an airport? So ICAO made the regulation of maximum permissible crosswind components based on ARFL, or airport reference field length, or the length of the runway. So for example, if a runway has the runway length 1,500 or more, so the maximum crosswind is 37 km per hour or 20 knots. And this is the other regulation or the other requirement. And FAA made the maximum permissible crosswind components based on airport reference code. This is the airport reference code, and this is the maximum crosswind for each airport reference code. So this is in kilometer per hour, and this is in knots. Now let's talk about the windrow's definition. In the beginning of the slide, we have discussed about how we decide the direction of a runway. So the direction of a runway decided based on the wind. But how exactly we decide the direction of a runway? So the appropriate orientation of the runway or runways at an airport can be determined through graphical vector analysis using a windrows. Or windrows is a graphical vector analysis to determine the orientation of the runway at an airport. So a standard windrows consists of a series of concentric circles. So this is the concentric circles. This is the circles, the second, the third circle, the fourth circle, the fifth circle, and the sixth, cut by radial lines. So this is the radial lines. This is the radial lines. Using polar coordinate graph paper. So if you make a windrows manually with your hand, so you can draw the windrows in a polar coordinate graph paper. The radial lines are drawn to the scale of the wind magnitude, such that the area between each pair of successive lines is centered on the wind direction. In the next slide, we will talk more about the windrows. So the windrows contained data, and the data need for draw a windrows is wind data collection, and minimum about 5 years. The wind data collection you can get from the meteorological climate station near the airport. So in a windrows, normally there are 16 radial lines in the concentric circles. So the 16 radial lines means 16 directions of the wind, like here. You can see 16 radial lines here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So the 16 radial lines is based on 16 directions of the wind. N, E, and etc. The N means north, N and E means north, northeast, NE means northeast, ENE means east, northeast, E means east, and the others. You can see here, this is the directions of the wind. So basically there are two types of windrows. So this is the first type, like this. The windrows type 1 only showing direction and duration of the wind. But we have the second type of the windrows that showing direction, duration, and intensity of wind, like here. And nowadays we just use the second type of the windrows because the first type of the windrows just showing the direction and duration of wind. So we use the second type of the windrows. So let's talk about the first type of the windrows that only showing direction and duration of wind. So this is the radial line. There are 16 radial lines, and the radial line show the direction of wind. So is the wind blow from is the wind blow to north or to north northeast or to northeast, and etc. So the radial line show the direction of the wind, and each circle show duration of wind. What is the duration of wind? Duration of wind is the percentage of time when the wind blows in the direction. So total here is 100%. If we sum it, is 100%. So the best direction of the runway is the direction with the longest line. And the second is the windrows that showing direction, duration, and intensity of wind. So the second type of the windrows also has 16 radial lines that show the direction of the wind, but the difference is each concentric circle show the intensity of the wind. The intensity is the velocity of the wind. So this is the smallest and more larger intensity or velocity to outer circle. And the difference from the first type of the windrows is in the second type of windrows there are numbers inside the circle or inside each segment of the circle that show intensity that show the duration of the wind or the percentage of time when the wind blows in the direction. So in the first type of the windrows, the duration shows here, but in the second type of the windrows, the duration shows here. If there is no number inside the segment of the circle, so it means that there are no winds blow in this velocity, in this direction.
مثلا عملت هاي. هسا مثلا لو انا حطيت الخطين هذول المتوازيين بهذا الاتجاه، شو هي الارقام اللي راح يمر فيها؟ حيمر في جميع هاي الارقام الموجوده بين 4 و 13%، او حتى من الواحد ل 400، من 4 و 13%، حيمر فيها جميعا. وحيمر كمان في مجموعه ارقام، فانا بدي اخليه يمر باكبر كميه من الارقام. فانا لو حطيته بهذا الاتجاه تقريبا، يعني هو حتى المثال محلول، لكن من اجل التوضيح، فلو حطيت انا تقريبا بهذا الاتجاه، حيكون انا عندي بمر في ارقام مثل 7.965 1.3 وال 1.4 وال 1.4.9.